Hello and welcome to another WJEC A level physics question. This was from January 2011's Unit 1 paper, and it was the first question. It's on basic electricity, which nowadays you'll find in Unit 2 of the WJEC specification. First part of the question asks us to explain what's meant by the electric current in a conductor. So here we're simply going to say that the current is the rate of flow of charge. Not quite enough to say it's a flow of charge, as you might have done at GCSE. That basically means it's the total amount of charge that passes a point per second, and hence for the second question where it asks us to identify which of the following is a correct alternative unit to the ampere, the correct answer is the coulomb, the unit of charge per second. For interest, the joule per coulomb is the volt, the joule per second is a watt, and the volt per amp is an ohm. Next we have a simple circuit where we have a 10 ohm resistor in series with a parallel combination of 120 ohms and 40 ohm resistors, and there's a total potential difference across the whole thing of 6 volts. We've got to write down the relationship between the currents Y and Z in the circuit, X, Y and Z in the circuit. Well, current X splits up into currents Y and Z, so we can simply say that X must be equal to Y plus Z. The next part of the question asks us which conservation law is that result of the previous part of the question a consequence of, and this will be consequence of conservation of charge. There are two conservation laws that apply to circuits: charge, which is anything to do with currents, and conservation of energy, which is anything to do with potential differences. In the next part of the question, we're asked to find the resistance of the combination of the three resistors. So we'll start by working out the resistance of the parallel combination. And remember that resistors in parallel add in reciprocal form, so 1 over the parallel resistance is 1 over 120 plus 1 over 40. Common denominator there would be 120, so we got 1 over 120 plus 3 over 120 gives 4 over 120. And that means that the parallel resistance is 120 divided by 4, which is 30 ohms. And the total resistance is the 10 ohms that was in series with that parallel combination of 30 ohms, giving us a total of 40 ohms. Next, we're asked to find the current X. So here we can simply apply current is potential difference over resistance, but we've got to be very, very careful what potential difference and what resistance we use. We can see here that the 6 volt potential difference is across the entire circuit. So if we were to replace that whole circuit with a single resistor, it would have a PD of 6 volts across it, a resistance of 40 ohms as we've just worked out, and the current of X passing through it. So to find the current in the circuit, we simply take the 6 volts, the PD across the whole circuit, and divide it by the resistance of the whole circuit. So 6 over 40, we can simply cancel that down to 3 over 20 or 1.5 over 10. So we're talking about 0.15 amps. The question continues by asking us to find the potential differences labelled as V1 and V2. So to calculate V1, we can use V equals IR. We know that the current for V1 is this current X passing through a 10 ohm resistor. So we have the current of 0.15 multiplied by 10 gives us 1.5 volts. We could calculate V2 in exactly the same way by multiplying the current by the resistance, knowing that the resistance of the combination was 30 ohms, and hence 0.15 times 30 gives 4.5 volts. Or alternatively, remember that the two PDs have to add up to the 6 volts of the supply. So a quicker way possibly is to say that V2 is the total 6 minus the 1.5 for V1, giving us 4.5 volts. Doesn't matter what method we use. Finally, to find the currents X and Y, well, to find Y or X we can use V over R again. We know that there's 4.5 volts where Y is, so if we look at the diagram, Y is the current passing through the 120 ohm resistor. So we're simply going to do 4.5 over 120 for Y, and similarly to that we're going to do 4.5 over 40 for Z. So if we just put those numbers into the calculator, we get 3 over 80 or 0.0375 amps for Y, and for Z 0.1125. And you'll notice that if we add those two currents together, we will be back to the 1.5 amps before the current split. Thank you very much for listening. Please remember to like and subscribe.